Hello and welcome back. We will continue looking at Chapter 5. We'll now look at Section 5.3, and we'll start by reviewing how to add fractions. Now, what we'll be doing in a little bit is we'll be going in reverse, but for the moment, let's just look at how we would add these two fractions, or in this case, we'd subtract the fractions. 3 divided by x minus 4 minus 2 over x plus 2. So the first thing that we'll notice is that the two denominators are not the same. So in order to add or subtract fractions, we need the denominators to be the same. So the easiest way to do this will be to do the following. If I have my two fractions here, what I will do is I'll multiply the top and the bottom of this fraction by x plus 2. And so I'll just put this in parentheses. So we'll multiply this by x plus 2, and then we'll multiply this guy by x minus 4. And the reason that we do this is when we look at the bottom of this fraction, the bottom of this fraction is going to be x minus 4 times x plus 2, and the bottom of this fraction is now going to be x minus 4 times x plus 2. They now have the same common denominator. So it's just easiest to multiply them all to get the same denominator on the bottom. So the bottom is now x minus 4 times x plus 2. So what is the top? Well, over here we had 3 times x plus 2. Over here we'll have 2 times x minus 4, but we're subtracting the fractions. So we'll end up subtracting this guy, and we now have everything as one fraction. We can simplify if we want to. I can distribute the 3. We'll have 3x plus 6 minus 2x plus 8 over the bottom, which I'm just going to leave as those two factors. And the top, we've got 3x minus 2x. Well, that's just going to leave 1x. And 6 and 8 will add up to 14. The bottom is still like this. And we have now added these fractions together. So the question that I want to address in this section is, if I gave you this as a starting point, could you pull them apart and write them as two separate fractions? And this is called partial fraction decomposition. So here I have the original fraction, I have a fraction which I've factored the bottom out, and we've written this as the sum of two fractions which we pull apart. And we'll notice that we've got two factors on the bottom, and our fractions have those factors as the denominators. So these are known as partial fractions. What is partial about it? Well, they have only one part of the denominator of the original fraction. So we've taken our fraction, we've split it up into two smaller, in a sense, fractions, where the denominator is just going to be individual parts of the original fraction. So it turns out that we can do this a lot. This is a very handy way of writing a fraction down. So here I have the fraction p of x over q of x. What does this mean? P of x is going to be some polynomial. For instance, maybe x plus 14. Q of x, we're going to restrict ourselves to thinking about when q of x has distinct linear factors. So let's break this down. Linear factors are things like x minus 4 and x plus 2. These are linear expressions. Linear means we'll only have something like ax plus b. There are no x squareds, so we won't see any x squareds, we won't see any x cubes. We want to be able to completely factor q into linear factors. Same way as up here. One factor is x minus 4, another factor is x plus 2. They also have to be distinct, meaning they all have to be different from one another. I have an x minus 4 here and I have an x plus 2. Those are different. This has two distinct linear factors. So when I can do that, when I can write p of x divided by something that is going to be a bunch of distinct linear factors, I've got the first one, the second one, I've got, let's say, n of them, I can then take my fraction and I can write it as the sum of n partial fractions. Notice that we have the same denominator here as the first factor. I have the same denominator here as the second factor, all the way out to the last one. What we notice on top, the capital A1, capital A2, all the way through capital AN, these are just numbers. There's no variables on the tops of these fractions. They're all just numbers. Let's apply this and actually use it. So we want to find the partial fraction decomposition of 5x minus 1 divided by x minus 3 times x plus 4. So using this formula here, I'm going to split this apart. Since I have two factors on the bottom, and they are both linear, they neither of them have an x squared or x cubed or anything like that. It's just x minus 3 and x plus 4. I can write this as the sum of two fractions. One fraction is going to have an x minus 3 on the bottom. The other fraction is going to have an x plus 4 on the bottom. What will go on top? Just some numbers. I will call them a and b. So, the question is, what are a and b? Well, this is where we'll just have to do some math to figure this out. The easiest trick to be able to figure these out is to get rid of all the fractions. I do not necessarily like working with fractions, so I'm going to get rid of all of these fractions by doing the following. We're going to multiply by the denominator here. I'm going to multiply by x minus 3 times x plus 4. And I'm going to multiply everything by this. And what you'll see is that everything will cancel and we're not going to be left with any fractions anymore. So on the left-hand side, I'm going to multiply this by x minus 3 and x plus 4. So this is times this fraction. On the right-hand side, I'm going to multiply this first fraction by this number. So I have x minus 3, x plus 4 times a over x minus 3. And then I'm going to add, and again, whatever we do to one thing, we have to do to everything. This is going to be b over x plus 4. So we've just multiplied everything by this number here. And we will watch as everything cancels. X minus 3 and x minus 3. Let me do this in red so it's a little bit easier to see. X minus 3 and x minus 3. X plus 4 and x plus 4. So the only thing left on this side is going to be 5x minus 1. So far, so good. Next, x minus 3 and x minus 3. So what's left over, I have some number a times x plus 4. Next up, we've got an x plus 4 and x plus 4 cancel, so now I'm left with b times x plus 3. Sorry, minus 3. And we are nearly there. The next step, I want to factor I want to expand everything. So let's simplify. So a times x plus 4 times a we've got b times x and b times negative 3. And what we'll notice is that I have some x's on both sides of the equation, and I have some numbers without x's on both sides of the equation. And the way this works is that the equation has to be balanced. If I have 5x over here, all of the x terms on this side have to add up to 5x as well. So since I have a 5x on the left-hand side of the equation, the ax and the bx on the other side will have to add up to 5x. And then the same with the constant terms. So if I have a negative 1 on that side, I have a 4a, there's no x in there. And over here, I've got a minus 3b, there's no x in there. So all of the constant terms will have to balance as well. And for the final trick, I'm just going to divide this top equation by x. So if I divide the left-hand side by x, and if I divide the right-hand side by x, all of the x's cancel. So now, two equations, two unknowns, I get to solve for a and b, just like we've been doing for the last couple of sections. So I'm just going to try to cancel some things here. I've got a b on top and a negative 3b on the bottom. So I'm going to multiply this top equation by 3 to get, so 3 times the 5, 3 times the a, 3 times b. On the bottom, I've got negative 1 is equal to 4a minus 3b. I add these together. The b's will cancel, and I'm going to be left with 7a. 15 minus 1, well, that's 14. So dividing both sides by 7, I get a is equal to 2. So far, so good. But my original equation here was 5 is equal to a plus b, and a is in fact 2. So if I subtract 2 from both sides, I get b is equal to 3. So I don't want to lose sight of what we're doing. So let's go back through quickly what it is we were trying to solve here. We were given a fraction at the very beginning, and we wanted to take this fraction and split it apart into two more fractions. The denominators of both of the new fractions should be the factors of the original fraction. So I'm trying to take this big fraction and split it up into two smaller fractions, and all of this work was to figure out what is a and what is b. So the first step, multiply by the denominator. So I'm going to multiply everything by x minus 3 times x plus 4, and we watched as most things cancel until we got this equation here. We expanded everything out. Next step, all the terms with x's in them have to balance. If I have 5x on this side, I've got to have 5x on this side. So the ax and bx have to add up to 5. And then I divide it by x to just get rid of that x. If I have negative 1 on this side, then the 4a and the negative 3b should have to add up to negative 1 as well. Two equations, two unknowns, solve for a and b. We can then plug these into our fractions here to get the following. We know that 5x minus 1 over x minus 3, oops, computer's lagging a little bit, x minus 3 times x plus 4 is going to be equal to 2 over x minus 3 plus 3 over x plus 4. As we just plugged in a is 2 and b is 3 into our original equation.